All right, about half of you, half the class is doing a real good job keeping up with these and you're turning in stuff. And I just checked this problems the other day, 4 through 55. And I didn't check every problem, just kind of took a look and see if you had a general idea of what's going on and gave you a grade for it. So if you're doing a good job, if you don't, if you see the rest of the people in the class sometimes, holler at them, tell them, go watch the videos, do the work and all that. It's not that hard. Because I gave you a bunch of examples and all that, and I think most of you got a good idea. But what I want to do today is I want to do a few more problems from that section so you can check. You check your homework. You check and see if you got them right. Again, there were so many problems I couldn't check, and I didn't check problem by problem to see if you had them all right this time. So you go check. Let me do some of these for you that were in the homework from page 273 and 274, number 4 through 55. First, number 13 here. Number 13 says 4x squared plus 32 is equal to 0. You want to solve this equation. Solve it, find out what's happening to the variable, do the opposite. It's being squared, 4 is being multiplied, and 32 is being added. So subtract 32 from both sides. You get 4x squared is equal to negative 32. Divide both sides by 4. X squared is equal to negative 8. And here, when you want to undo what's happening when x is being squared, take the square root of both sides, and when you do it, you do take plus or minus the square root of this side. So you get x over here is equal to plus or minus the square root of negative 8. And again, this is where a couple weeks ago we would have said, oh, you can't take the square root of negative 8. Now you know you can. Now you know you break it up into the square root of negative 1 times the square root of 8, or I times the square root of 8. And the square root of 8 has a perfect square factor of 4 in it. So break that up into the square root of 4 times the square root of 2. So that you can say that's 2 times the square root of 2. And your final answer would be like this, 2i times the square root of 2. Okay? So your final answer would be plus or minus 2i times the square root of 2. Alright? Or he said, it's I right here, and then this is 2 times the square root of 2, but you would write it like this. So there's two answers here. Solution set is negative 2i times the square root of 2 and 2i times the square root of 2. There's two answers. If you took either one of these answers and plugged them into the original problem, it would make it a true statement. Plug it in for x, it would make it a true statement. So you can check that sometime. Here the instructions were simplify the square root of negative 13 times the square root of negative 26. This is one of those cases where you multiply two imaginary numbers together and you're going to come out with a real number. But let's see how it works out. The square root of negative 13, you would break that up into I times the square root of 13. This would be times I times the square root of 26. Okay, and the square root of 26 has obviously a 13 in there, so what's going to happen when you multiply these two together, you get I squared right there. 13 times 26 is whatever it is. I know whatever it is. It's got, let me show you the factors that it has in it. It's 13 times 2. If you think of 26 as being 13 times 2, you have this. The reason I just chose to wrote it like this was because I know the square root of 13 times 13, which is 169, that is equal to 13. So watch this. Now I squared, remember I squared? I squared is negative 1. Not the square root of negative 1. I is the square root of negative 1, so I squared is just negative 1. So it's negative, and the square root of 169 is 13 times the square root of 2. And so we were able to break down this square root once we multiply it out into that right there. So that's simplified form. So simplifying this was pretty easy, right? You're just subtracting. Addition and subtracting is easy. Just do like terms. 3 minus 1. 3 minus 1 is equal to 2. Negative 4i minus negative 4i. We'll just watch all the minuses here. Negative 4i minus negative 4i is the same thing as plus a positive 4i. So negative 4i plus 4i is 0. Final answer is just 2. When you multiply out, do it like FOIL, multiply like binomials. Every term over here times every term over there. So it's 1 times 2, which is 2. 1 times I, which is I. Negative 4i times 2 is negative 8i. And negative 4i times I is negative 4i squared. All right? And then when you simplify, you combine your like terms, like the middle terms there. You got 1i minus 8i is negative 7i. And here you have 2. Okay, so what's I squared? I squared is negative 1. So negative 4 times I squared is negative 4 times negative 1, which is plus 4. So that's 2 plus 4. Final answer, 2 plus 4 is 6, minus 7i. Again, combine only the like terms. Don't try to combine the constants and the i's together. All right? And this one, we said what's not simplified about this is you have a radical in the denominator, because I is the square root of -1. What you want to multiply by is the conjugate of the denominator. In other words, the conjugate, the reason that we choose the conjugate is because that's going to get rid of the i's altogether in the denominator. We don't really care what happens at the top, okay? We want to do it right, but we don't care if we end up with i's up there. But we don't want any i's at the bottom, okay? So we choose the conjugate of this. So the conjugate of 5 plus 3i, just change the sign. It's 5 minus 3i. And you can only multiply by a well-chosen 1, so you have to multiply by that over itself. Okay, so at the top, 4 times 5 is 20. 4 times negative 3i is negative 12i. At the bottom, 5 times 5 is 25. 5 times negative 3i is negative 15i. 3i times 5 is 15i, plus 15i. And 3i times negative 3i is negative 9i squared. Okay? So this is what always happens when you multiply by the conjugate, is the middle term adds out, because you're always going to get just the opposite, right? You're going to get a positive 15i and a negative 15i. So that goes away, that's 0. And then the other thing that happens is you get an I squared over here, which is not imaginary, it's real. I squared is negative 1. Okay, so let's see, what I have at the top is 20 minus 12i. So hold that thought just a second. At the bottom is 25 minus 9i squared. Okay, so I squared is negative 1. So negative 9 times negative 1 is a positive 9. So I got 25 plus 9. And that's going to be 20 minus 12i over 25 plus 9 is like, what, 34? All right, I was about to circle this, but I can't quite circle it because I noticed there's a common factor of 2 everywhere that I could divide out. So if I factor a 2 out of the top, 2, 10 minus 6i, like that. And at the bottom is 34. So divide the 2 out of that, and 17 is what I got left. So final answer, 10 minus 6i over 17. Same thing over here. Here's another one, same thing. Just multiply by the conjugate over itself. So multiply by 3 plus 4i over itself. And let me just go through this one more time. So it's a binomial up here, every term over here times every term over there. 2 times 3 is 6. 2 times 4i is 8i. Negative I times 3 is negative 3i, and negative I times 4i is negative 4i squared. So we'll simplify that in a minute. Here, 3 times 3 is 9. 3 times 4i is 12i. Negative 4i times 3 is negative 12i. See, that always happens like that, right? Negative 4i times positive 4i is negative 16i squared. And again, I squared is negative 1. So let's see, at the top, what happens? We have a 6 up here. We have 8i minus 3i is 5i. And negative 4i squared is negative 4 times negative 1, which is plus 4. And at the bottom we have 9. The i's go away. And then we have minus 16i squared. So minus 16 times negative 1 is plus 16. And let's see, maybe my final answer. No, not quite. 10 plus 5i over 25. I was hoping I'd be able to circle that, but it just so happens there's a common factor of 5. So I factor a 5 out of the top, and I get 5 times 2 plus I, and out of the bottom, when I divide out that 5, I'm left with 5. 2 plus I over 5 is final answer. All right, so if you have any questions about this assignment at all, maybe write me a little remark, and how did I get this, or what did I do on this, or something that I can work some more for you if I need to. But that's pretty much it. Moving back to a section that we skipped a while back, it's on dividing polynomials. And I've got just 4 homework problems for tonight, but it involves dividing polynomials. When you have an expression like this, all of it divided by this, you're just basically dividing each term. Each of these terms is being divided by 4xy. And so it's a fairly simple procedure in the sense of 4x cubed y squared divided by this. Remember, when you divide, you subtract the exponents. Remember the old rule, if you multiply like this, x squared times x to the 5th is equal x to the 7th. When you multiply, you add the exponents. When you raise a power to a power, you multiply the exponents, right? X to the 4th to the 3rd power is equal to x to the 12th. And when you divide, like x to the 10th over x to the 8th, you subtract the exponents, okay? And so that's what I'm using here when dividing, so I'm going to subtract. First of all, 4 divided by 4 is equal to 1. All right, so it's just 1 like that. X cubed divided by x, so basically subtract the exponents. 3 minus 1 is 2, x squared. And y squared over y to the first is just y. So basically you can think of, hey, I'm just dividing one of the y's out of that, or you can think of it as subtracting 2 minus 1. So you get x squared y plus, and 8 divided by 4 is 2, x over x, the x's go away, and here y squared over y is just y. Over here you got minus 12 over 4 is minus 3, and then x squared over x is just x, and then y cubed over y is y squared. Okay, so I don't think I have any like terms here, so I'll just circle this and call it my final answer. But again, divide the coefficients by the coefficients like you would expect, watch out for the signs like you would expect, and then the variable expressions, just remember when you divide, you subtract the exponents like that. So let's try these 4 to start with, and then I'll show you some more long division and synthetic division, ways to divide polynomials, so you'll be able to divide by a binomial or a trinomial or something more complicated like that. But on page 236, 4, 5, 15, and 16, so let's see if I can show you those. Page 236, 4, 5, 15, and 16 are all on this page right here. Really can't see. I think I got it for you right there. All right. So if that didn't come out right, text me back and I'll try to correct it. But let's get all these done. Keep up with all this stuff. And if there's some problems, if some assignments you hadn't done in the past, go back and check those. Don't just get zeros for everything. See y'all next time.